How do data analysts use a visualization grammar to create plots for visual analysis? We hope to show you that it's important to study visualization grammars in this context, and we have some findings from a qualitative study. First off, I've briefly defined visualization grammar. It's a set of components that map data onto the visuals. The grammar of graphics is the original grammar. To make a scatter plot with it, we first start with the data component. Here are variables a and b. On the other side, we have the visual, called geometry. In this case, the point and many others like lines and bars are possible. And the data and geometry components are connected through an aesthetic mapping data onto properties of the geometry, in this case the x and y coordinates. Other properties or aesthetics include color and size. This grammar may sound abstract, so an analyst might write code like this to specify the scatter plot. This is ggplot and our implementation of grammar of graphics. Visualization grammars are good in theory because they're expressive, being able to produce a wide range of plots. Theoretically, grammars are also modular and flexible, easy to change, and have concise and consistent syntax. No wonder there's been a proliferation of grammars ever since the original grammar came out. Like ggplot we just saw, and Vega Lite has a big ecosystem around it, and there are many more reviewed by this recent paper. Turns out in practice, however, we know little about how analysts use visualization grammars in their work, even though they should benefit from grammars being expressive, concise, and so on. Existing user studies may ask participants to recreate visualizations, but we haven't asked participants to explore and iterate like in real life. More specifically, we're lacking the context of analysis and workflow. But data wrangling should be a big part of the visualization process as depicted in various models, like the reference model shown here. So how do we capture the iteration and data wrangling context while evaluating these popular visualization grammars in practice? In this paper, we answered these two questions with a qualitative study with video recordings and interviews. TidyTuesday is a data science community for the R language. From this community, we recruited 6 participants who are intermediate to advanced ggplot users in both academia and the industry. Our participants wrangled and visualized fun data sets of their own choice with ggplot without instructions and recorded their analysis processes with Think Aloud. This is a screenshot from one participant where they started from data exploration and ended up tuning boosted tree models. Our thematic analysis combined the video recordings with retrospective interviews we did with each participant. We then annotated edits participants made to their analysis code, namely addition, change, or deletion of grammar components in green, and data wrangling verbs such as filter in blue. And this is how we put together an edit log for each participant. Now we want to highlight some of our major findings around how participants iterated on their grammar specifications and the interplay between grammar specifications and data wrangling. I want to show you this example about how a participant iterated using ggplot. They started with this area plot, and these are all the changes they made in between. V's for visualization edit, and D's for data manipulations. And they ended up with this faceted version in the end. Here edits are incremental. The participant iteratively updated the plot, changing a single feature at a time, like what the grammar promised, and they never had to start over. This is in line with the benefits of using a visualization grammar. On the other hand, participants devised their own informal plot templates and shortcuts in analysis. They copied and pasted code chunks like templates to make similar plots elsewhere in their analysis, but mistakes can happen, like forgetting to update some variables and messing up with sorting in this example. Of course, plot templates go against the grammar philosophy. In addition, participants wanted to customize their plots, but in this recording clip, the participant had to go back and forth with the angles to align text labels to this circle. Given the plot templates and troubles with customization, we can have opportunities to make visualization grammars more practical for analysts. The question is how we can integrate these needs with analysts' workflow using grammars. For instance, making customization as easy as mapping data onto aesthetics. Aside from iteration, we looked at the interplay between grammar specifications and data wrangling, and we found a feedback loop and tight coupling. The feedback loop means that the participants edited grammar specifications after wrangling the data, and vice versa. From this area plot example, the participant filtered out the magenta category to see the rest of the data better. For the tight coupling between visualization and data wrangling specifications, I will explain with an example. Two participants wanted to compute, say, the top 5 categories in their dataset, and they wrote code for data wrangling and plotting. But this is the output. 50 categories instead of top 5. What was wrong? Turns out the data wrangling corresponds to the top 5 categories conditional on the year variable. There are different top 5s each year. On the other hand, the grammar specifications actually correspond to a cross operator between categories and year, so no conditional logic. Here, the underlying specifications between wrangling and visualization are not in sync. To fix, we can either take out the conditional in data manipulation at the top 5 categories overall, or add a conditional in the plot specification. With faceting, it's clear that each top 5 is conditional on the year. This example demonstrates the tight coupling. Visualization and data wrangling specifications depend on one another, and the two going out of sync can cause problems. Maintaining the consistency between visualization and data wrangling can be another area for future visualization grammars to improve upon. Though not visible to the analyst, there is a shared underlying algebraic representation behind the visualization grammars and data wrangling. Ideally, a consistency-aware grammar implementation can identify and explain any potential mismatch to the analysts. Stepping back a bit, I think our findings are possible because we study the visualization grammar where it's used, in data analyses. If we look at visualization tools more broadly, we can have different degrees of integration between visualization and analysis. We have none at all, like specialized systems that assume clean data. You can wrangle data a little bit in Tableau-like interfaces, and you can do any analysis on any number of datasets in an environment like computational notebooks. In a notebook environment, we found the feedback loop and the tight coupling. These are good things. They empower the analysts. On the other hand, analysts can make mistakes and can use some design and support, but we are only beginning to see the kind of work in visualization literature. More broadly, what can visualization grammar contributions look like in computational notebooks or other environments with this high degree of visualization analysis integration? And what can we learn or enable analysts to do in this world?